Hi, my name is Nerges Matini. Thank you for listening to the presentation of our poster. You might be wondering, why do we need to calibrate the layer coefficient? The NCDOT uses Ashto design equation to design flexible pavements. And the layer coefficients they are using in this equation are the same coefficients proposed from ASHA road test in 1960. Paving materials have changed a lot since then, and as you can imagine, current practices do not reflect these changes. To show this problem, we have these two graphs presented here as examples. You can see calculated PSI using default coefficients do not match with the observed PSI from in-service pavement section. So the objective of our research is to calibrate the layer coefficients and then evaluate the impact of using those coefficients on pavement performance and design. The calibration process that we are using is summarized in this fellow chart here. We calculated PSI for about 80 pavement sections with different structures and road types. We used Ashto equation and we started with initial values for layer coefficients. Then we changed those coefficients until the calculated PSI matched with the PSI converted from PCR for those sections. But how did we convert PCR to PSI? First, we developed deterioration model for PCR, and then we developed another deterioration model for the collected IRI for those sections. And then we found a correlation between these two indices. Then we used an equation from the literature to convert IRI to PSI. You can see the correlation and equations summarized in these figures and table here. Also, we're conducting lab tests on loose mixes from different regions of North Carolina, and we're trying to evaluate the modulus and resistance to rutting and fatigue for these mixes. Then we are going to use these results to perform simulation analysis to find a correlation between performance of current mixes and past mixes. And then we are going to use this correlation along with layer coefficients we calibrated to find layer coefficients for current mixes. Our research is still ongoing, but we'd like to share some of our preliminary findings here. First, we found out the calibration results are very sensitive to initial PSI and the deterioration of PSI. Also, the preliminary calibration results vary section by section. We see both increase and decrease in calibrated coefficients comparing to default values. Also, the results of our performance tests showed that the modulus for current mixes comparing to reference mixes is lower, which means we're expecting to see lower rutting resistance but higher fatigue resistance for current mixes. I will be happy to answer any question you may have, so feel free to contact me. Thank you.